Hello, everyone. I am Sara Hassan from Packet Clearinghouse. I work at the outreach team where we help and work with every internet exchange points and every network who would like to do a DNS Anycast network, or if we would like to host a node there in their equipment, so in their data center, so we help them to do that. Before we start, I just would like to give a quick note about what is PCH. Maybe it's not familiar for all of you. Packet Clearinghouse is a non-for-profit organization based in the US. It has been started for more than 25 years, working on helping building the biggest DNS Anycast network in the world that hosts a lot of CCTLDs and a lot of top-level domains for the DNS, and that will help to make the DNS resolutions for our queries fast and very quick. Okay, here I'm going to give a talk about what is the Anycast network and why this is benefit and what is the benefit from it, and yes, and what is the benefit from having a node that if we at PCH would like to host in Myanmar, that will be a very nice, and we will be very excited to do that. So Anycast technology, first, it's the technology or the term of Anycast. It's used in a network for a long time. The main idea for that is you have multiple nodes with the same IP address, and these nodes will be replicated in different location. That will definitely make a confusion, like how come, because we used to have like IP address need to be unique on the internet. So how come I can have the same IP but duplicated? So here, this is a trick of Anycast. You have same IP address, different location. And when a client try to query that IP address, it will go for the nearest location to it. So you may have the IP in different locations, but the only node that will reply to you, that one will be nearest you according to your routing, according to your how your network is going to deliver the packet to which instant. Okay, so that's Anycast. The main topic, the main application that's use this trick, because it's one of the critical infrastructures that we really needed to be fast. It's a DNS query. We need it to be very fast because it's small, and that will help to make your connection very good. So one of the technologies that's used the Anycast is DNS. Okay, for PCH, we do have a biggest Anycast network around the world, as you can see here on the map. We have a different location or different nodes that's not having a DNS node that have a lot of CCTLDs, as I mentioned, the top-level domain, and a lots of zones for DNS. So all these .URCA, this is the places where you can find a node for PCH. So, for example, if you are in some country, let's pick my country, I'm from Sudan. From Sudan, if I would like to query anything related to, let's say, google.com, for example, the nearest node will answer my question. That will be in my location, and that will be hosted in my country. If there is nothing hosted in my country, then the query will be forwarded in the nearest place. And as you can see here on the graph, there's a lot of dots in hello, can you hear me, or I lost the voice?
You're still good, Sarah. Thank you.
Okay, thank you. So as you can see, there's lots of dots maybe in America, and some lots of dots in Europe, and in Africa, North Africa, it's still not a lot. So that's something we really would like to help, because that will definitely make the internet better for them. And also in Asia, and that's one of the things that we are doing. And we will be very happy to host a node in Myanmar, because we don't have there, and we definitely would like to be there. So that also will help the local queries, or the local DNS query for Myanmar networks will be very fast. Okay, I give a scenario here. That's a slide we have done before 2 weeks for one of the companies in my country. We will try to show them that what is the benefit from Anycast and what's the benefit from having it inside your continent or inside your country, and what is the benefit you will get. So if you looked for that, if you can see the slides on the left side, that we are trying to trace route for this IP address 9.9.9.9.9 from one of the network. And we know that this 9.9.9.9, this host is already inside the country. It's already inside Sudan. So this country, when they try to trace route that IP address, they don't go through the node that's already hosted inside the country. They are doing some kind of, I don't know, that maybe they need to fix their routing, and this is what we are teaching them, and what's that we are telling them. Like if you're trying to reach that node, if you see the steps that you are taking too much of steps until you arrive there. You are going overseas to reach something that's already inside your country. And as you can see in the slide, let's go to France. So from Sudan to France, that's like they are traveling like thousands of kilometers to arrive at host. But if you can see the slides on the right side, that's one of the network. They are doing already peer on the exchange point, and they are doing a good routing table for their environment, for their network, so they can reach the quad name, the host, by only 2 hop, as you can see, only 2 AS numbers, and then they arrive. And that's definitely a huge difference. As you can see, the round time table for the traffic to go and come back, that's like from 130 millisecond, and that will only be for the other network, it's only 1 millisecond. So that's a very huge difference, and that's the important things for having Anycast nodes inside your country. That will help for reducing this time, and of course that will make your queries very fast, and yeah, as you can see, it's a huge difference. Other thing that we would like to show you that we grabbed some graph from DNS query. As we know, the DNS is a UDP, so it's stateless. So having the concept of Anycast, that's it works very good with it. And this is a number of the queries, just to give you like idea about the queries that can happen every day. So we can have like more than 20,000 per day for all these queries. For IPv4 and IPv6, Anycast work with both of them perfectly fine. But we would love to see more. IPv6 is still in developing, as not all the networks are doing it, but there's some. So we would love to see the IPv6 also traffic to go far as IPv4. Another thing we would like to highlight, the PCH Anycast network, the number of the queries, as you can see. This is one of the most important slides that we would like to highlight. We do have in PCH local nodes, as we see them on the graph in a multiple location. We do also have global nodes that's located in a big countries, where we do have transit from two tier 1 networks. That's Lumen as well as level 3 and sorry, NNT. So these global nodes, we can see the traffic for them. They are very big comparing with the local node. Why this happened? This happened because most of the network operators who are running networks or running exchange point or whatever the network they are running, they don't give attention for the routing table, and they don't give attention for how the packets is flow in the internet. So most of them, or most of the queries, we can see it's come to the global node rather than it comes to the local node, and that's something we don't want to see. We want it's wasting for your resources, wasting money, and that's taking lots of time for your query to come to reach the destination. So one of the things that we would like, and we also do at PCH, we teach them how to fix the routing and how to get the benefit from the local node, because as we said, that will help you even to develop your economy, to make your internet better, and lots of things. So that one of, as you can see, the global nodes, they are taking a lot of traffic, and we would like to reduce that as much as we can. And the rest of the node, local node, will be the biggest one, and that's a target. The fourth graph that will show you the traffic by continent, by region. As you can see, Aran and Rayab, they have like lots of traffic because they, as we see in the graph, there's lots of internet exchange point there, or lots of locations. We do have nodes, but we would love to increase also the graph in ethnic region, and that's what we are trying to do now. And because of that, we are very happy and excited to have a node in Myanmar. That will be nice. And also for Afrinic and Africa region, we also would like to increase the number of the nodes there. For Anycast node, if you would like to host an Anycast node, what's the things that you need to do? Normally, we get invitation by internet exchange points, or we reach to them that we tell them what we are doing, and we would like to host a node there in your exchange point, in your facilities, and we teach them what is the benefit they will get. Of course, that will be a huge difference, as we say, already as we saw in the graphs. Some of them they prefer, like, the internet is already working, we get the reply from another global node, but no, that's something this should not be your target. You would love to have the traffic locally as much as we can. As BZH, we are a non-for-profit organization, so we have limited resources. And of course, if we can deploy in each node and each site. But normally, we are very happy to implement and deploy in each location. We get an invitation, or we can ship our equipment there. So that's all for my slides. It's some hope that give you an idea about what is the Anycast and what is the important for it, and why we should have it a local Anycast node in our country. And yeah, and I'm welcome for any questions or any comments. Thank you.